Hybridization. After doing the valence share electron pair repulsion theory, we know that we can easily give the structure of any polyatomic molecular species, but definitely a very important question is remain unanswered, and that the question is how these polyatomic molecular species are formed, how they attain their different shapes or geometry. So in order to explain the formation of the polyatomic molecular species, simultaneously their structures or shapes or geometries, whatever we can say, Pauling and Slater gave the concept of hybridization. It is also called extension of the valence bond theory VBT, because valence bond theory mainly it talks about the diatomic molecular species, but whenever it comes to polyatomic molecular species, it's extended to form or to the concept called hybridization. So the basic of hybridization is very similar to VBT, like which says the overlapping of the orbitals takes place in order to form the bonds in the polyatomic molecular species. But first, let us do the main features of this hybridization. The main points are, first point, what is hybridization? It is the intermixing of atomic orbitals of comparable energies just before the formation of bond to form new type of orbitals called hybrid orbitals having similar shapes and equal energies. So the most important is it is the mixing up of the atomic orbitals of comparable energies. I am talking about the atomic orbitals of the central atom, which is always the least electronegative. So the intermixing of the atomic orbitals of the central atom just before the formation of a bond to form new types of orbitals, which are called hybrid orbitals, which are having similar shapes and equal energies. So this is what is hybridization, the main feature is. The next point. The combining atomic orbitals must have unpaired electrons with opposite spins. If combining atomic orbitals have paired electrons, they form lone pairs. Next point, the number of hybrid orbitals formed is always equal to number of atomic orbitals combining. The geometry or shape of the molecular species is decided on the basis of the shape of the hybrid orbitals. Now, the shape of the hybrid orbitals shape or geometry of the hybrid orbitals is decided in a way to have minimum interelectronic repulsions, which is the basic of the, which was also the basic of the valence shell electron pair repulsion theory. So these are the few basic points in this. Always remember, next point, hybrid orbitals only form sigma bond. Pi bond is not formed by them. Another important feature, hybrid orbitals have similar shapes and equal energies. They have higher tendency of combining than atomic orbitals because they are more directional. So overlapping is more for greater extent in these cases, so they have a higher tendency. So these are the main features of the hybridization concept.